Hi. Today we are going to discuss about time complexity of algorithms. Time complexity of an algorithm is the amount of computer time needed to run the program to get the result. The time complexity of a program is calculated in terms of executable instructions of the function or program. So, we need to identify what are the executable instructions in the function or program and how many executable instructions are there in a program. For example, assignment statement is considered as executable instruction. Comments are non-executable statements. Variable declarations are non-executable statements. Decision making if is executable instruction. Return is executable instruction. Loop is executable instruction. If loop body is executed n times, loop control will be executed n plus 1 times. Loop means it is a repetitive statement. So body of loop will be executed repeatedly many times. How many times means maybe n times. So when loop body is executed n times, loop control will be executed n plus 1 times. For example, let us consider a first statement. For I assigned to 1, I less than or equal to 5, I plus plus, printf 5. So I starts with 1, ends with 5, and I is increased by 1 every time, and every time if condition is true, a printf statement gets executed. If I is less than or equal to 5, printf 5. So when I is 1, print. When I is 2, print. When I is 3, print. When I is 4, print. When I is 5, print. When I is 6, it terminates. When I is 6, it terminates. So printf will be executed 5 times and loop control I is compared with 6 also. So 6th time also it is going to be compared. So loop control executes 6 times, loop body executed 5 times. In general, loop body executes n times, loop control will be executed n plus 1 times. Now let us consider a small function. To find time complexity of an algorithm, find sum of first n natural numbers. Say for example, if n is 5, if n is 5, sum of n natural numbers is 1 plus 2 plus 3 plus 4 plus 5, which will be 15. For this we have written some program here, function int find sum. N is your input, n may be any natural number. So we are going to find 1 plus 2 plus 3 plus etc up to n. So we need to find 1 plus 2 plus 3 plus etc up to n. Initially sum is taken as 0. For I assigned to 1, I less than or equal to n, I plus plus, sum is sum plus I. Then return sum. In this function, what are the executable instructions we have to identify? Function name is non-executable instruction. Variable declaration is non-executable instruction. Open brace, closed brace are non-executable instruction. Variable declaration is also non-executable instruction. Sum is 0 assignment instruction. For loop control executable instruction. Sum is sum plus I executable instruction. Return is an executable instruction. So see what are executable instructions, what are non-executable instructions we have written. Then how many times these executable instructions are going to be executed or repeatedly executed. Sum is 0 will be only executed only once, one time. Then return is also executed only one time. What about this for? It is a loop, number of times it repeats, it is going to be repeatedly executed many number of times. How many times? 1 to n, 1 to n. For I assigned to 1, I less than or equal to n. So sum is equal to sum plus I will be executed n times. The for control will be executed n plus 1 times. Whatever the loop it is, if the loop body executed n times, loop control will be executed n plus 1 times. So what are the total number of executable instructions in here? 1 plus 1 plus 1 3. There are 2 n's, 2n plus 3. The total number of executable instructions are 2n plus 3. So the time complexity for every instruction, it takes some time. So we are identifying the time complexity directly proportional to the number of executable instructions. Here the number of executable instructions are 2 into n plus 3. So in terms of Big O notation, the time complexity is considered as order of n based on the given equation. 2n plus 3, it depends on n. So order of n is the time complexity of algorithm to find sum of n first n natural numbers using loop, using iteration. Now let us consider one more function to find sum of elements of an array using a loop iteration again. We are going to find time complexity of a function which is going to find sum of n values of an array. Say an array consisting of some number of values, say for example 5. 5 elements are there in the array, 0, 1, 2, 3, 4. So array name is A. Assume that array contains 10, 20, 30, 40, 50. For example, the array contains 5 elements. I wanted to find sum of all the elements. For example, here we have taken 5 elements. It may be any number of elements. It may contain n number of elements. So addition A is array, n is number of elements in the array. Then we are going to find elements because index starts from 0 and ends with n minus 1. 0 and I less than n. I is 0, I less than n, I plus plus. So sum is sum plus a of I. So this will be repeated n times and this will be repeated n plus 1 times. It is given in here n times n plus 1 times. Then what are the executable instructions? What are non-executable instructions? Int addition, program function name, non-executable instruction, variable declaration, then open brace, closed brace, variable declaration, all are non-executable instructions. Sum is 0, assignment instruction, for loop as executable instruction, sum is equal to sum plus a of I, executable instruction, return is an executable instruction. See, there are 4 executable instructions. There are 4 executable instructions, but here there is a loop. This loop is going to be repeated many times. So how many number of times this executable statement is going to be executed repeatedly, we have to identify. So sum is sum plus a of I is executed n times and the loop is executed n plus 1 times. The total number of executable instructions are 2n plus 3. So it is order of n. We write the program or function based on the logic and we identify what are executable instructions, what are non-executable instructions, and we count the frequency of the statements, how many number of times these executable instructions are getting executed. So then finally we count all the executable instructions or statements. So total number of statements that are getting executed. Based on the equation, we identify the time complexity. Here it is again 2n plus 3. If it is 2n plus 3, the time complexity is considered as big O of n or order of n. Again, let us take one more function. Time complexity of algorithm to find factorial of a given integer number using again iteration loop. See here, there is a function. This is not executable instruction, non-executable instruction, variable declaration, non-executable instruction, f is equal to 1, executable instruction, for executable instruction, assignment executable instruction, return executable instruction. Then how many times it is executing? So fn is 1, only one time it executes. For is a loop, so loop control f into f is fn is fn into I. So how many times this is going to be executed means here I is 1, I less than or equal to n. 1 to n. 1 to n times this fn is fn into I will be executed. So n times. When the loop body is executed n times, the loop control will be executed n plus 1 times. Then return statement, it executes only one time. Again it is 2n plus 3 order of n. Here based on the logic, see what is the logic? Suppose if n is equal to 4, factorial n is 1 into 2 into 3 into 4. So every time I is varying, initially fn is taken as 1, then we are repeating fn is fn into 1, then it is 1, fn is fn into 2, fn is fn into 3, fn is fn into 4, 24. Like this, 4 times the loop will be executed. 4 times the loop will be executed. So for loop control will be executed 5 times if n is 4. So in general, n times the loop body is executed, loop control is executed n plus 1 times. So the total number of executable instructions are 2n plus 3, which is order of n. Now let me explain the time complexity of algorithm to find factorial of a given number using recursive method. See, there is a recursive function factorial int n. If n is equal to 1, return 1, else return n into factorial n minus 1. So exactly this will be executed in this fashion. For example, if n is equal to 4, if n is equal to 4, for example, if n is equal to 4, we call factorial 4 function. We wanted to find factorial of 4. N is 4. See here, track the instructions. If n is equal to 1, it returns 1. Otherwise, it returns n into factorial of n minus 1. So this returns 4 into factorial of 3. Again, there is a function called factorial 3. When you call factorial 3 function, again these statements are getting executed. If n is equal to 1, no, it is not 1. So return n into factorial of n minus 1. 3 into factorial of 2. Again factorial of 2. So we call again factorial function. So factorial of 2, n is 2. Is n 1? No. Else n return n into factorial of n minus 1, 2 into factorial of 1. Again factorial function. Is n equal to 1? Yes, n is 1. So it returns 1. 1 is not our result. It has to be back substituted in the previous equation. So factorial 1 is 1. 1 into 2, it is 2. It is factorial 2. Factorial 2 is 2. That is substituted here 3 into factorial 2. 6. 6 is factorial 3. So this is substituted for factorial 3. 4 into 6, 24. What is 24? The value of factorial 4. So this will be written. 24 is getting written. So this is the procedure. So in this procedure, what are the executable instructions and how many number of times these executable instructions are getting executed, we have to identify. If you just consider this function, function name is not a executable instruction. Variable declaration is also not an executable instruction. If is an executable instruction, return is an executable instruction, and again there is a return instruction. So return is an executable instruction. How many executable instructions will be executed if you call once? If n is equal to 1, either return statement or this return statement. So if one executable instruction, either this return instruction if it is true or if it is false, this instruction. So it executes one if and one return statement. So two executable instructions. If you call a factorial function recursive function, there is a possibility of getting two executable instructions, but because this is a recursive function, there is a possibility of calling the function many number of times. For example, in this particular example, how many times this is getting executed? When n is 4, factorial function is called 4 times. See, one time, second time, third time, fourth time. So when n is 4, factorial function may get executed n number of times, n times. Every time when you call a function, there are two instructions, executable instructions. So 2 into n number of executable instructions. When there are 2 into n number of executable instructions, automatically the time complexity will be order of n. Order of n. See here, when n is 4, there is a possibility of calling 4 functions. So recursion means it calls the function again and again inside. So how many factorial functions are there? 1, 2, 3, 4. Every time there is a possibility of only two instructions, if and return. Either this return or this return. But there is a possibility of executing the same instructions many times. How many times this is called? 4 times. If n is 4, 4 times. If n is 10, 10 times. If n is 100, 100 times this get executed. Every time there are two executable instructions. Total is 2 into n number of executable instructions. 2 into n number of executable instructions means 2n means the total number of executable instructions are. Let us consider one more recursive function to find time complexity. Here the recursive function is to find sum of first n natural numbers using a recursive function. So what is it? Sum of first n natural numbers. Suppose n is equal to 4. We need to find 1 plus 2 plus 3 plus 4 using recursive function. In a recursive function where the function calls itself many times. See here, find some n. We are going to find sum of first n natural numbers. So what are n natural numbers? We have to identify here. If n is equal to 0, return 0. If n is 0, it returns 0. Otherwise, it returns n plus find sum of n minus 1 natural numbers. Because you don't know the sum of all numbers, n plus sum of remaining numbers you are calling. See here, find sum of 4. We don't know what is the sum of 4 numbers. So, we are just calling 4 plus. Again call find sum of remaining 3 numbers. Then here, find sum of 3 means 3 plus find sum of 2. Then find sum of 2 is 2 plus find sum of 1. Then find sum of 1 is 1 plus find sum of 0. We know what is sum of 0. N is 0, then it returns 0. Now this is going to be substituted back. 0 is substituted in this previous one. 1 plus 0, 1. This one is substituted in find sum of 1. 2 plus 1, 3. Then this 3 is substituted in the previous one. 3 plus 3, 6. Then this 6 is substituted here. 4 plus 6, 10, and 10 is substituted for find sum of 4. So in this way we get the final result. While doing this, how many number of executable instructions whenever you call a function? See here in this particular function, in a recursive function, there is an if statement, executable instruction. If it is true, return statement is getting executed. So it is an executable instruction. Either first return statement or second return statement is getting executed. Both are not executing at the same time. So whenever you call if function, if instruction, if this is true, either this return statement is executed or this return statement is getting executed. Anyway, whenever you call a function, there is a possibility of executing only two instructions. There is a possibility of executing only two instructions per function call. Then how many function calls are there? 1, 2, 3, 4, 5. When n is 4, 5 function calls. In general, if n is something, if n is 10, 11 function calls. N is 100, 101 function calls. Then it is said to be, if it is n, n plus 1 function calls. For every function call, two instructions, n plus 1 function calls means n plus 1 into 2, 2n plus 2 number of executable instructions. If it is 2n plus 2 number of executable instructions, the time complexity will be order of n. Don't get confused. So there is a function, there is a possibility of executing only two instructions, there is a possibility of executing function call n plus 1 number of times. So this is a recursive function. Every recursive call will have two executable instructions, if and return. The function will be called n plus 1 number of times. So total executable instructions will be 2 into n plus 1, 2n plus 1. So the time complexity will be order of n. Thank you.